Hi, and welcome to Year 12 SDD, Maintaining Software Solutions, Lesson 1 and 2. Here are the syllabus dot points. Please pause if you'd like to read them. Firstly, what is maintenance? Maintenance is the altering of a system to enable it to better perform its function. And we have maintenance for a variety of reasons. We might have a change in user requirements, so the system might need to do something different because the user needs it to do something different. We might have an upgraded user interface. We might make it more pretty and more organized, more functional, more efficient. We might have a change in the data that needs to be processed. So the system that feeds into our system might have differences, and we need to cater those differences. Maybe we've got new hardware or software. We've upgraded our hardware, it's not compatible with our software anymore. Or maybe we've upgraded our operating system and we need to make it either more compatible or actually compatible because it's not compatible anymore. Maybe there's a change in organizational focus. Maybe our organization did one thing and now it does something slightly different. And so we can change our software to better meet that new focus. There might be changing government requirements. For instance, with tax software, you might find the government changed the GST, and so we need to change that. You might find there is differences in keeping records or whatever. So any change in government requirements could trigger a change. And the biggest and most common reason we perform maintenance is poor code. So bugs in the code preventing the software from doing the purpose it is designed, from performing the purpose that it is meant to be doing. Process of maintenance is really important. It needs to be performed correctly so we don't change our code all the time for no reason. And to enable this to happen, we follow the design process in full. So we define the problem again, we design the solution, we implement and we test. With defining the problem needs to be explicitly defined to enable someone to solve it. The person solving the problem needs to have as much information about the problem as possible in order to solve it. And they get this from a whole range of places, including existing source code, the existing design documentation, test reports, and so on. The exact section or sections of code that need to be altered are identified at this stage, and benchmarks are defined that clearly state what the new modified system needs to do to be deemed successful. In designing the solution, in this stage, documentation needs to be created or modified to suit the new solution. So we write new algorithms, for instance. As we use design documentation to define the problem, we need to make sure that all the design documentation is kept up to date to ensure that further modification at a later date is possible. We also design changes to online help in this stage. Also, we look at the exact changes that need to be made to the original code and we define them here. Implementing the solution. Once it's implemented, once the solution has been designed, it is time for it to be implemented. And the program will either alter or write new sections of code as needed to complete the solution. It's extremely important the program adds comments to the code to explain the new modifications, including at the top of the module to detail the changes made. And these look like this. So we can see here we've got the name of the system, the program name, the author, the dates, and so on. We've got the purpose of the program at the moment, and we have details of each change that was made and why it was made, and so on. So this enables a programmer to look at the code, see its history, know exactly what it's doing now and what it used to do, and they can use that to help them make future changes as necessary. We also then need to test and evaluate the solution. So we look at the modifications that we've made, we test them, we design tests that test the new functionality of the system and ensure it matches or exceeds the original performance of the system, as well as meeting benchmarks set down in the defining the problem stage.